Hello everyone, welcome to Cartesian, and in this video we're going to be looking at parametric equations. So parametric equations are a very interesting part of basically pure mathematics, in fact even basic mathematics, because they require you to have a certain level of calculus. So if you haven't done calculus, then parametric equations are going to be quite challenging. So you can go check out the calculus video, then come back to this video. So let's say we have been given y. Let's say we have been given y is equal to 2t squared. And then here is where it gets interesting. Let's say you have been given x is equal to 4t. Now let's say they want you to find dy dx. Let's say they want you to find dy dx of such. Remember that when finding dy dx, we normally have two variables and we do not have something like this. So it's going to be quite complicated in sorting such a problem out, but this is where the implicit function comes in. Remember, we said dy dx could be equal to dy dt, and then this will be times dt over dx. So that you'd have a point where dt and dt would cancel, and then you get dy dx. So if you agree with my math, we can proceed. So if we have written it in such a situation, now this is where you have to be very careful. So I can say my dy dx will be equal, what is my dy? So I can say my dy will be equal to d, and then this will become 2t squared. That's a gist. And then over dt, and then this will be all multiplying I can now put my dt here, my other dt, which will become d of 40 over my dx. So you have basically done dy dx. So what do we get after differentiating that? We're going to obviously obtain 40, and then that will be times, once we differentiate a constant which is raised to the power 1, we know that the answer is basically the constant. Yeah, so what do we get here after multiplying? We get 16t. So that is the basics of the implicit function and of the parametric equation. So now let's look at this other part of the parametric equation. This is just going to be a skim through of everything. So let's say they want us to express y in terms of x. So notice that in a parametric equation we are given three variables. So let's say they want us to express y in terms of x. So let's say we have been given y is equal, let me just write the same 2t squared, and then x is 40. So if they want us to express y in terms of x, what we can simply say, we can simply make t the subject of the formula, because t is what appears here. So if we want to make t the subject of the formula, we're simply going to have t is equal to x over 4 to x over 4. So now we're simply going to replace this t there into our equation of y. So now our y will become 2, and then now our t squared which will be x over 4 squared. So once we simplify everything here, we're going to simply get x squared over 8. Yeah, so this is the base of it all. But now let's talk about the Cartesian equation, because the Cartesian equation is something that I feel is overlooked and is very vital when it comes to this type of equation. So let's say x is equal to 2t and y is equal to t squared. So we can make x in form of y, so in form of t. So we can say make t the subject formula, and then t will be equal to x over 2. So now where we have t, we can replace. So now that will become y is equal to x over 2. Now this is going to be squared. So we're going to have x squared over 4. So this is simply the Cartesian So this is simply the Cartesian coordinate. So let's say we wanted to draw the actual Cartesian. So I'm simply going to get that my x, so I can simply say y is equal to x squared over 4. And then what I can simply do is I can bring in the box of values x, y, and then we can simply make simple substitutions. So let me make my range from -2 to +2. So they will have -2, -1, 0, 1, 2. So we're going to have a small grid just like this one, and then we're simply going to start substituting in. So once we have -2, we're going to have -2 squared, which is 4. Let me just show that. Remember, this should be in brackets. So then this will be just 1 if I'm not mistaken, because that will be 4 over 4, which is 1. Yeah, so then that is 1. So for the first one, we're simply going to have 1. And then now let's solve when we have got -1. So we're simply going to have -1 in brackets squared over 4, which is 1/4, 1 over 4, and then 4 into 1. So this is just going to be 1 over 4. 4 into 1, that is 0. Put a point, add a 0. 4 into 10, that is 2. Remember 2. 4 into 20, it can't. Put a 0 there, that's 5 if I'm not mistaken. So that is 0.25. So 0.25. Oh, seems like my box is too small. 0.25. Yeah, so that's 0.25. Yeah, so like we're going to simply keep on replacing until we're going to find. So that is 0.25. And then here, once we replace 0, we're going to have 0, 1, we're going to have 0.25 again. And then once we replace with 2, we're simply going to have 1. So now these are our coordinates. So now we can go ahead and draw our graph. This is just a rough scale. And then so we know this is the x, and then this is the y axis. And then now let's put our x coordinates. So our x coordinates, we said -2, negative 1, and then we say, so this is the origin 0, and then here we'll have 1, we'll have 2, and then for y we had a lot of decimal figures. So for y we had 1, so 1, and then we had 0.25, which is quarter, so I think I can start with 0.25. So we're going to have 0.25, and then here we're going to have 1, and then we're simply going to have the same 0.25. This is just a rough draft, and then we're not going to have other y values. So then now we just have to simply plot the coordinates. So negative 2, 1 is simply going to be somewhere here. I think 1 dot would be enough. And then negative 1, 0.5, negative 1, 0.5 is going to be somewhere here. 0, 0 is simply the origin right there. 1, 2.5 is simply here. Then now we have 2, 1, which is here. So then our graph will be going to be looking something like this. So that this is a graph of x squared over 4. So we have gotten over the basic graph coordinate. So if it were just a rough sketch, what I was avoiding to do is just to show you that the graph would be something like this. This was what I was avoiding to do. I was just avoiding showing the points. I wanted you to see at least the basic plotting of the graph, though it is not as neat as I would like it to be, but that's just the basics. Let's go ahead and clear all this. And then what you need to also understand about parametric equation is that everything in math is connected. So we're going to have the parametric equation, we're going to connect it with a little bit of some trigonometry, and then see what we get. So let's say they want us to find let's try something else. Let's say they want us to find the parametric equation of x is equal to 2 plus cos theta and then y is equal to 3 plus sine theta. So I can simply make my cos the subject of the formula and plug in my x equation into y. So I can say my cos, I can say let my cos theta be equal to x minus 2. So I have my value of cos theta. And then now, this is a very critical thing that you have to remember. You have to always remember that sine squared theta plus cos squared theta is equal to 1. This is an identity. So very important identity here. So if we are to make our sine theta the subject of the formula, we're going to have something like sine theta is going to be equal to the root of, if we make the subject of the formula, 1 minus cos squared theta. So, but now remember that this is cos theta. So we're simply going to say sine theta is equal to 1 minus my cos now of theta, which is x minus 2 squared. Squared. Yeah. So now that I'm at this stage, all I have to do is work through the whole math, and then we should have a plus 3 somewhere. Yeah, so we had a plus 3 for that y, so there should be a plus 3 right here. Sorry for the mistake. So we had a 3 plus here. Even here we should have that 3 plus. So then now our sine theta will be equal to 3 plus, and then now we'll have 1, and then once we evaluate this in the root, we're simply going to have minus x squared plus 4x plus 4. And then if we want to get rid of the root, what we can simply say is that as much as this is our sine theta, it is our y of things. So I can bring in my y, and say y, once this crosses the equal sign, it becomes y minus 3 is equal, and then let me square this, so that they should come out of the root, and then that would be simply minus x squared minus 4x minus 3. And then now once we reach this stage, we're simply going to have this side, we're simply going to have y squared minus 6y plus 9, and then it's simply going to be equal to this same one. And then now we can simply collect our terms, and then notice that you have got x squared and y squared. So if you are very good, you have to remember that this is going to be something to an equation of a circle. So this is a standard representation of an equation. So this parametric equation was actually a parametric equation of a circle. We've collected the like terms, that's how we've obtained the 12. So this was basically it on parametric equations. I know the math is complicated, but once if you go through each step by step, I'm sure you get a hang of it. But otherwise, this was what the equation should look like. So this is our final answer. So if you have enjoyed the video, please subscribe to the channel, like, and I'll be seeing you guys in the next video. Thank you very much.